Hello everyone, welcome to our discussion of section 3.4 where we will talk about solving equations that have radical expressions in them and solving equations that have rational expressions in them. Okay. Before that, I'd like to remind you to please skim through the textbook, spend half an hour to 45 minutes reading through section 3.4. Then watch this video and attend class and take careful notes of the things that you read or see that might be important to you, and also write down any questions that you might have. Anything that you see or read that is not making sense to you, bring those to my attention along with your questions. And then review your notes and then go back to the textbook section that you skimmed through and solve all those problems that the book has already solved without looking at those solutions. At the same time, come back to the video and solve all the problems that I have been solving in these videos without looking at the solutions. And then, of course, complete all the homework by the due date and review, spend half an hour a week reviewing the previous material. That's all it takes to keep things fresh in your mind. Okay, so in this section, we begin by first determining what is an LCD. I'm sure you've seen this before, or the least common denominator. Least common denominator can be used to add or subtract fractions that do not have a common denominator. But in this case, when we solve equations that have rational expressions in them, we want the LCD in order to be able to multiply both sides of the equation by that LCD to clear all fractions at once. So let's get started by looking at the first example here. And in this case, we are not solving. Notice that we are not solving any of these examples. We are just looking for the least common denominator, which would help us then to multiply both sides by the LCD to clear all the fractions at once. Not individually, but all fractions must be cleared at once. Okay, so here, what number could we choose, or what expression can we use to multiply both sides of this equation by to clear all three fractions at once? Okay, so let me give you an example of what not to do. I'm going to do that on this scratch paper that I have in front of me. So sometimes when I give an expression like this on an exam, so suppose we have 1/4 and plus 1/5 equals 1t, 1 over t. Again, this is an example of what not to do. So you have people who want to clear, these are various wrong solutions that I've seen. So somebody is going to do this to clear this fraction. They're going to do this, multiply this by 5, and multiply this by t to clear that fraction. Totally wrong. This individual, which I've seen things like this on exam papers, this individual has used 3 different things to clear the fractions. That's not acceptable. We cannot do that. Another case I've seen, which is again an example of what not to do, is when someone has done this. So we have, suppose that expression equals 1 over t, and this person says, okay, I'm going to multiply this side by 20, and I'm going to multiply this side by t. Again, this is a wrong approach. Why? Because the entities, both sides of the equation, are being multiplied by different things. So this side is being multiplied by t, this side is multiplied by 20. That is not right. Okay? If you do this correctly, both sides of the equation must be multiplied by a single term such that that single term clears all three fractions at once. All three at once. Very important. And it should be the single term, not different values. So what would you say we have to multiply both sides of this equality by in order to clear all three fractions at once? All three at once, very important. And it should be one single term, not different things as you saw in the examples that I just showed. Okay? So to clear all three fractions at once, the LCD would be 20t. So the right side must be multiplied by 20t. The left-hand side must be multiplied by 20t. So this would be the right approach, times 20t and all of that times 20t. Notice that 1 over t is being multiplied by 20t. All of the left side is being multiplied by 20t. The same terms are multiplying the equation on both sides. So here we're not solving. We're just figuring out what that LCD should be to clear all these fractions. Very soon we'll get to the same examples where we will actually solve these. But for now, I want us to make sure, I want to make sure that everyone knows how to clear all fractions in a rational equation like that. Okay? So this one, what would you say is a single term that we can multiply both sides of the equality by to clear all three fractions at once? Okay, so what do you think that is? Think about it. It should be 6x, right? So LCD is 6x. So we should multiply this side by 6x and multiply all of that side by 6x. You see that? Both sides of the equality must be multiplied by a single term to clear all fractions on both sides, not different things. Next, what do you think would clear, what LCD would clear both fractions at once? Well, if you said the LCD here, is W minus 7, you're absolutely correct. So that would be this side multiplied by W minus 7 and all of that side multiplied by W minus 7. Do you see that? Both sides must be multiplied by the same thing, not different things. Here, on this side, we have just one fraction. So what do you think we should multiply both sides by to clear that one fraction? If you answered x, you're absolutely correct. So in this case, LCD is just x. Here, LCD was two terms, right? W minus 7. And then on the left, also multiply by x. Here, that's an interesting case. See, here we have m plus 2 and m. Can this be factored? Can this denominator be factored? No. Can this denominator be factored? No. Can this denominator be factored? Yes, and we must factor it. If we don't factor it, we won't know what LCD is. To find the LCD, we must factor this denominator. And that's an easy expression to factor. If you remember let me bring this back, my scratch paper here. Do you remember that we had, if you have x squared minus y squared, if you have that, in other words, if you have a perfect square minus another perfect square, We had a special product formula for this, right? This is one of the 3 special product formulas that I've asked you to memorize. So this will factor into x plus y times x minus y. Every time you have a perfect square minus another perfect square, you can factor that expression into this. Okay? So, m squared is a perfect square. 4 is also a perfect square, right? 4 is 2 squared. So let's write it down. We have 3 over m plus 2 plus 2 over m equals 4m minus 4. The numerator can be factored too, but at this point we're looking for LCD. So never mind the numerator for now. Just focus on the denominator. So that is m squared minus 2 squared, right? So a perfect squared minus another perfect squared. Just like the situation we have here. A perfect squared minus perfect squared equals x plus y times x minus y. So how can we factor this then? We can then say 3 over m plus 2 plus, let me move this up, 2 over m equals 4m minus 4 divided by m plus 2 times m minus 2. Okay? Now that we have factorized the denominator, we can look for LCD. Only if you have factorized the denominator, you can look for LCD. Okay? Please don't forget that. This is critical. So now, let's look for the LCD. LCD is one full term such that we could multiply both sides by it and get rid of all these fractions at once. Okay? Let's see. So the LCD, so now that we have the denominators in factored form, we can look for the LCD. Okay, so what is the LCD? So the LCD must be able to multiply all these fractions by and clear all fractions at once. So the LCD, should it have m plus 2 in it? Absolutely. Should it have m in it? Absolutely. Should it have m plus 2 in it? Yes, but it already has. It already has. So m minus 2, absolutely. Now suppose, now this is our LCD for this problem. So we're done. We should multiply both sides by that, this side and that side by that, in order to clear all fractions at once. Okay? So we're done with that. But suppose that m plus 2 here was to some higher power than 1. Suppose this was m plus 2 cubed. Then what impact would that have on the LCD? The LCD must contain each factor in the denominator in the highest power it appears. I know we're calling this the least common denominator. That's true. But that also means that any of these factors that you see here must appear in the highest power that it appears under any single fraction. So the reason that none of these have higher powers than 1, it's because none of these factors have higher than 1 power under any single fraction. So power of m plus 2 is 1, power of m plus 2 is 1. So you see the m plus 2 to first power. If m plus 2 was to third power here, under this fraction, then in the LCD we would have m plus 2 cubed to third power. So once again, the LCD must contain each factor from the denominators in the highest power it appears under any one fraction. Okay, I hope that makes sense. Next one. So I've done A, B, C, D, E. I've done 4 examples so far. So please, if you haven't done this already, pause the video and find the LCD for these last 2 problems, F and G. Okay, I'm counting on you to have the tenacity to do this before looking at my solution in the video. Okay, I'm counting on you. All right, so I'm assuming you've done that, and now you're back. So in this denominator, now this is appearing in the denominator, so we must be able to, we must think about factors of each of these. Can this be factored? Yes. So let's write each of these with factored denominators. So 4 times x plus 3. Okay. Can that denominator be factored? Yes, because this is x squared is a perfect square, and 9 is a perfect square. Remember that? What do we do when we have perfect squares subtracted from each other? We can find the factors as follows. So a perfect square minus another perfect square equals x plus y times x minus y. Right? In this case, x squared, so in this case, let me write it down in a perfect squared form. So x squared minus 3 squared, right? So we do have this form. We do have this form, which we can then factor into this form. X plus y times x minus y. Okay. On the right, can we factor the denominator? No. So let's write it down as it is. Now let's simplify this a little more. So we have 1 over 4 times x plus 3 minus, we got to factor this now, x plus 3 times x minus 3. Okay, equals 5 over x minus 3. Now, are all denominators in factored form? Yes. Now we can look for the LCD. Okay. So, should the LCD have a 4 in it? Absolutely. It's a factor in the denominator. It should be in there, in the LCD. Should the LCD have x plus 3 as a factor? Absolutely. What is the highest power for x plus 3? 1. Just 1. In both cases, it has a highest power 1. So we include it with power 1. If you had x plus 3 squared here or here, then in the LCD, we would include x plus 3 squared. Okay? So the LCD must contain each factor of the denominators in the highest power it appears. Now, what's the next factor? X minus 3. That should be in LCD too. Is there anything else? Is there any other factor we should include in LCD? No. So the LCD is that. So do you see why you should factorize the denominator before you look for the LCD. If you don't know the factors of that, for example, you won't know that what factor to include here. You might miss it. In this case, you have x minus 3 from here and x plus 3 here, but what if this was 5 over, say, x? Right? So then you would, if you don't know how to factor this, you would miss x minus 3 as a factor, because x minus 3 is a factor of this itself and this expression. I hope this matches the answer you wrote down on your paper. Okay, so I'm assuming you've already found the LCD for this one, part G. Okay, I'm assuming you've done that. So please don't skip it. All right, so now let's hope that our answers agree. So, can this be factored, this denominator? No. Can this be factored? No. Can this be factored? Yes, because 1 is a perfect squared. Right? So let's write it down like that. X over x minus 1 minus 1 over x plus 1 equals 2 over x squared minus 1 squared. 1 squared is 1, right? So once again, we're able to write the denominator there in this form. A perfect squared minus another perfect squared, which we know gets factorized or gets factored in this form. X plus y times x minus y. Okay, so let's do that here. Then, factoring these two are fine. So we write down x over x minus 1 minus 1 over x plus 1 equals 2 divided by x plus 1 times x minus 1. Right? Have we factored all the denominators as much as they can be factored? Yes. Can we now look for the LCD? Yes. So let's do that. The LCD is any of these factors in the highest power it appears under any one fraction. So x minus 1 to first power, we should include it. X plus 1, yes, we should include it. Over here, the same factors appear, but with the same power. Power 1, right? So do we have to include them again? No. Okay, so this is our LCD. Again, the LCD is very important because that is the term or combination of terms like that you have to multiply both sides of a rational expression by to clear all fractions at once. Okay? All right. So this was such an important exercise that we had to learn how to do this before we can solve rational expressions. Now, one more thing, we also need to go over how to solve radical equations before we can start solving examples. So let's go through this. This paragraph is a summary of what's in your book. It says if you have one radical expression, if you just have one in your equation, then make sure that the radical equation is one side of the equation by itself. I should have said is on one side of the equation by itself. Okay? Make sure that the radical equation is on one side of the equation by itself. So if you have a radical expression, you want to isolate that radical expression on one side and put everything else on the other side of the equation. Then raise both sides of the equation to an appropriate power. Appropriate power is whatever the root is, or the index of the radical expression is, whatever that is, then you raise both sides of the equation to an appropriate power. What does that mean? Let me explain that. Suppose we have a radical equation like this. Square root of x minus 5 equals 2, right? Suppose we have to solve this equation for x. So what should we raise both powers of this equation to? We should raise both sides to the second power, right? But why? Why second power? Why not fifth power or eighth power? Well, because the index of this radical expression, this index value, is missing, which means if it's blank, it means it's 2. I can write it. It's not incorrect, but by mathematical convention, if that number is 2, we don't write it. But because that index, that's called the index of the radical expression, because that index is 2, in order to solve for x, we must raise both sides to the second power. Okay? So the appropriate power to raise both sides to is the second power. How about if this index was 3? Cube root of x minus 5 equals to 2. Then what? Should we again square both sides? Absolutely not. It would make no sense. Because it would not make sense because if this index is 3, raising both sides to second power would not clear this radical expression. The purpose that we do this, raise both sides to second power, is because this 2 and this 2 cancel each other out. That's why. And some of you might be wondering, why is that? How can that cancel this out? Well, remember that all radical expressions can be written in terms of a rational exponent. So we can write this like this: x minus 5 to power 2 over 2. 2 over 2. That number divided by that number. So, but 2 over 2 is 1. So we get x minus 5. The power is 1, it's just gone, right? That's why that power, if it's equal to the index, they cancel each other out because of this situation. If it's 3, if this is third root and that's 3, 3 over 3 is 1. So again, they cancel each other out. So that power must always be equal to this if we wish to omit the radical expression. So if we have a scenario like this, then to get rid of the radical expression, we must raise both sides to which power? What would be the appropriate power to raise both sides to? 3, right? It should be equal to that. So we would say third root of x minus 5 cubed equals 2 cubed. So because of that, on the left we end up with x minus 5. On the right we end up with 8. So what about if we had fourth root of x minus 5 equals 2? Now what do we do? What would be the appropriate power to raise both sides to in order to get rid of the radical expression? Well, it would be to the fourth power, right? So we'd say this side to fourth power, this should be equal to that to get rid of it, and this side to fourth power. On the left, we would have x minus 5. On the right, we would have 16. Do you see how that works? Okay. But for this to happen, we must make sure that the radical expression is on one side by itself. Everything else, you send it to the other side. It doesn't matter what it is. It doesn't matter if it's a variable, if it's a constant, if it's whatever it is, you send it to the other side. Okay? That's what that is saying. Then raise both sides of the equation to an appropriate power to get rid of the radical expression and solve for the variable. Now after that, it's very important. So this whole paragraph is very important. If you have two radical expressions, let me highlight that. If you have two radical expressions in an equation, make sure that they are on opposite sides of the equation before raising both sides to some power. So if you have two radical expressions, let's say something like this. Suppose you have something like this. Square root of x minus 3 plus square root of x equals 9. Right? In this equation, you have two radical expressions. You got to make sure, before you solve this, you got to make sure that these are on two opposite sides of the equality. So you want to make sure to do this. Square root of x minus 3 equals 9 minus square root of x. So we sent this square root to the other side. It was positive. When we moved it, it became negative. So now they're on both sides of the equality, not on one side. So now we can raise both sides to the second power and go from there. Continue the solution that way. Okay? That's what that is saying. If you have two radical expressions in an equation, make sure that they are on opposite sides. Okay? That's what I did. I moved this to the other side. So the radical expressions are on opposite sides of the equality. Okay? So this is pretty critical. Opposite sides. Like that. Okay? So, if we have, this is just an identity from the past. I believe that maybe we might have covered this in either Math 95 or Math 96. So, one of the earlier algebra classes. So, if you have two terms that are equal to each other, then if you raise both sides, those two to the same power, n and n, they're still equal to each other. Okay, just remember that. Then this is also important. When we are solving a rational equation or a radical equation, this is a very important note. You must check your answers in the original equation to see if they work out. So just because you end up with, suppose you use these techniques and you end up with x equals 2 and x equals -1. You cannot accept these answers as true unless you go back, plug those answers in the original equation, and see if they work out. That step we must do for all of these. Okay? All right. Now it's a good time for you to pause the video and write your answers. Treat each video as a test. You can easily pause the video. Like I've said before, these videos are not meant to be watched like as if we are watching a movie of some kind, or a program, or any TV program. You shouldn't just watch it. You should pause repeatedly and before you see my solutions, and solve the problems on your own, and then unpause the video and look at the solutions. Okay, so let's get started, and we have to check our answers. Remember that. So I'm assuming that you've already solved these two problems, A and B. And now you're here to watch my solution. Okay, so I'm looking at this, and this is the one that we've seen before, right? One of the ones for which we figured out the LCD. We know that the LCD for this is 20t, right? 20t will clear all three fractions at once. So 20t times 1 over 4 plus 1 over 5 equals 20t times 1 over t. Okay? Both sides must be multiplied by the same terms, not different terms. Okay, now I want you to distribute but not simplify. I have seen at least half of my students in each class, they know what they're doing, but because they're combining two things at once, they make plenty of errors, at least half of the class. So they distribute this and simplify at the same time. So they make plenty of errors. Don't do that. Okay? Almost 19 years of experience teaching this subject can't be wrong. I've seen this happen again and again. Don't combine two things at once. Do it one at a time. One chore at a time. So first distribute, then simplify. How's that? This is how that happens. So 20t, I'm just going to distribute, I'm not going to simplify, times 1 over 4 plus 20t times 1 over 5 equals, now on that side, it's already been, we can do the same thing. So 20t times 1 over t is 20t divided by t. Okay? Now let's simplify. So 4 is a factor of 20, right? So it goes away, and with 20 we end up with 5. So 5t. Now we can simplify. 5t. Okay? How about here? Well, 5 goes away. We end up with 1. And with 1 from 4. And 5 is a factor of 20. That goes away. We end up with 4. So 4t. So plus 4t. Equals, on the right side, we have t's cancel out. We end up with 20. Okay? So now we have, add these. We have 9t. We're solving for t, so we need to isolate t. 9t equals 20. Is t isolated yet? No. Why not? There's a 9 next to it. What do we do with 9? We divide, to get rid of 9, we divide both sides by 9 to isolate t. T is equal to 20 over 9. Okay? I hope this matches the answer you have on your own paper. Next one. Again, I'm betting on the fact that you've already solved this. So, the LCD here must be a single term that would clear all three fractions at once. That would be 6x. Okay? So, let's multiply both sides of that equation by 6x. 6x times 1/3 minus 5 over 6 equals 6x times 1 over x. Okay? Do we distribute and simplify at the same time? No. I'm asking you to distribute but not simplify. How's that? This is how is that. 6x times 1/3 minus 6x, right? We're distributing. No simplifying. Times 5 over 6 equals 6x over x. Right? Now let's simplify. So the 3 is a factor of 6. So this goes away, we have 1. The 3 factor of 6 goes away, we have left 2. So 2x. So that reduces to 2x. How about the second term here? Well, the 6 and the 6 go away. We end up with 5x. Right? Then how about on the other side? The x terms go away. we end up with 6. Okay? So all three fractions are gone, and we multiply both sides of the equation by single term, not different terms. So what do we have now? 2x minus 5x, it's minus 3x equals 6. Is x isolated yet? No. Why not? Because we have a negative 3 next to it. So how do we get rid of the negative 3 to isolate x? We divide both sides by negative 3. So we have x equals 6 over minus 3 minus 2. So one thing we should do, and I'm going to do this in a, I don't know if because I don't have room on this paper, but we should check. So let me do it on a piece of scratch paper here. We should check all these answers. So check that answer. Okay, let's check it. So we're going to put it back into the original equation to see if both sides are equal to each other. We need to do that before we go to the next page. Okay, so checking, once we check that, I'm going to also check this negative 2. Okay, but let's do it for part A first. So 20 over 9. Okay, so checking t equals 20 over 9 in this. So we have 1 over 4 plus 1 over 5 equals 1 over 20 over 9. Well, this is, because it's 1 over that, it's taking the reciprocal of this. So what do we have? We have 1 over 4 plus 1 over 5 equals 9 over 20. It's just taking the reciprocal of that. Okay, so all right, we're asking, are the two sides equal to each other? Is this side, left side, equal to that? Let's find out. For that, we need to take the common denominator, right? The common denominator is 20. So, is this, right? The common denominator is 20. So, is this 20? No. We should get it to be 20. So, multiply it by 5. But can we do something like this to the denominator and not do the same thing to the numerator? No. So we must also multiply the numerator by 5. Compare this 5 with the common denominator. Is that 20? No. So what do we need to do? We need to get it to be 20. So how? We multiply 5 by 4. Can we do this to the denominator and not do it to the numerator? No. So we must also multiply the numerator by 4. So what do we end up with? We end up with 20 for both fractions, which is equal to the common denominator, which means we can now add the numerators. 5 times 1, 5, plus 4 times 1, 4. 5 plus 4 is 9 over 20. Is that equal to this? Yes. So it checks out. Okay? Our number checks out. We're good. So we can accept that answer. How about the negative 2? Let's check it. Let's check it here. I'm going to write it here. All right? So we have 1 over 3 minus 5 over 6 equals 1 over minus 2. Notice I replaced x with minus 2. Why? Because we're checking to see if the left and the right sides are equal. So what's the common denominator on this side? 6. Right? If we are right, then the left side should also be equal to minus 1/2. So the common denominator is 6. Is this 6? No. What do we need to do? We need to get it to that. So how do we do that? We multiply the denominator by 2 to get it to be 6, equal to the common denominator. Can we do this to the denominator and not do it to the numerator? No. So 2 times 2 times 1 over 2 times 3. Now let's look at this denominator. Is that equal to the common denominator? Yes. Then do we need to do anything here? No. We leave it alone because it has a denominator equal to the common denominator. So 2 times 1 minus 5. That is equal to minus 3 over 6. Is that equal to negative 1/2? Are the left and the right sides equal to each other? Yes. Minus 3 over 6 is minus 1/2. So it checks out. So we can accept that x minus 2. So because I didn't have enough space to write the check part on the worksheet, I'm just going to say check. Check this answer. So just as a reminder, and there is also here, it says remember to check your answer here. So to remind you that with rational expressions and radical expressions, you must check your answer. You can't just accept it right away. Okay? All right. So let's go to the next problem. On this page, we have 3 problems. Let me put them so that you can see all 3 on the screen, like that. Go ahead, grab a piece of scratch paper on your own, write these problems down, pause the video, write down your own solution, and compare it with this. I'm assuming you're interested in getting an A in this course. So I'm showing you the path and the strategy you need to use to get an A in this class, and that's the strategy. Don't just watch my solutions, please. Make sure you solve these problems ahead of me before you unpause the video and see the solutions on your own. Okay, so I'm assuming you've done that. You've solved all 3 and now you're back. Okay, let's see. Here, the LCD to clear both fractions at once is W minus 7, right? So let's multiply both sides by the LCD in order to clear the fractions. Like that. So now we can distribute. I mean, we can do, it's already there, but if you prefer visually, we can write it like this. We can say W minus 7 times 49 divided by W minus 7 equals W minus 7 times W squared divided by W minus 7, right? Okay, so now let's simplify. W minus 7 and W minus 7 cancel out. They cancel out only and only because they are being multiplied by the numerator. W minus 7 is being multiplied, not added or subtracted from 49, but multiplied. That's why we can cancel it. If you had W minus 7 added or subtracted to 49, we could not cancel it with this. Okay? On this side, the same thing. That goes away, so we are going to end up with this equation. On the left, we have 49. On the right, we are left with W squared, right? Let's switch it so the variable side is on the left, like that. This is no different than that, okay? So now, let's take the square root of both sides, right? Square root of W squared equals square root of 49. Is this correct? Is my answer correct? So W equals 7, am I correct? Or is there something that is missing? Do you remember what's missing? This answer is not correct, but what's wrong with it? Well, by the square root property, if you remember that, we must have plus or minus. So we end up with 2 solutions unless this is calculating a distance of some sort, say the radius of a circle. or the distance between 2 points, then you would only accept the positive value. And not that you don't have a negative result. You do, but you toss it out. So when you have some equation like this that relates to calculating a distance of some kind, the radius of a circle, the distance between 2 points, you will toss out the negative piece. Okay? But here we're not calculating distance, so we must accept both answers. So W is equal to plus or minus 7. Like that. Okay? Next one. What is the LCD here? What term would clear the only fraction in this expression? X, right? LCD is X. This is one of the problems we solved earlier for the LCD. Remember that on the first page? So, I'm asking you, once you figure out the LCD, multiply both sides by the LCD, but don't simplify at the same time. Multiply, first distribute, then simplify. That's what I'm asking you. Okay, so how's that then? It's like this. Once we figure out the LCD, multiply X, right, by both sides. So X times X minus 12 over X equals X times 1. Okay? So now distribute X times X. Do not simplify, just distribute. Minus X times 12 over X equals, that side it's okay. We can just write down X. Okay, it's okay. X times 1 is X. Now, on the left, let's simplify. X times X is X squared minus minus. X times 12 over X. So this X and this X cancel out because this is X is being multiplied by 12. So we end up with minus 12. And on the right, we already have X, right? Okay. So now we have a quadratic equation. Let's bring this to the left and set it equal to 0 and solve for X. So we have X squared minus X, right? It's positive on the right. When I move it to the left, it becomes negative. Minus 12 equals 0. So this quadratic equation is a very easy equation to factor, right? These are easy numbers to work with. So the factorization is X minus 4 times X plus 3 equals 0. Okay? So if you FOIL this, you get that back. All right. So let's set each factor equal to 0 and then solve for X. So if X minus 4 equals to 0, then X equals 4. If X plus 3 equals to 0, that factor, then X equals minus 3. Should we accept these two? Not yet. We have to check both of these numbers back into the original equation to see if it checks out. Let's do it on my scratch paper. And I'm hoping you've done this at home already. So you know which one checks out, which one doesn't. Or both of them might be acceptable. We don't know. I mean, I don't know at this point. I have to check. So using that, using X minus 12 over X equals 1, we're going to check. Let's check X equals 4 to see if both sides are equal. So 4 minus 12 over 4 equals 1. So 12 over 4 is 3 equals 1. Are the two sides equal? Yes, so it checks out. So now let's check x equals -3. So that one checks out. That one checks out. We can box that and say it's okay. We accept it. Now we have to check -3 back into the original equation. Let's see. So I'm going to plug in -3 here. -3 minus 12 over -3 equals 1. We're asking if this is true, if both sides are equal to each other after we plug in -3, right? So -3 minus 12 over -3, it's -4, right? Equals 1. We're asking if that is true. Okay? So -3 minus -4 is that equals to 1. And this is 1 equals 1, so yes, it checks out. So we just checked, and both of these answers check out. That's fine. We accept both. Okay? Now, part E. I'm hoping that you already have solved this. If not, it's not too late. Pause the video, please. Write down your own solution and then come back to this. And this shouldn't take you more than 5-6 minutes at tops. If it takes longer, it's still worth it. Do it on your own, then come back to the video. Because you're working on two things, on your accuracy and speed. Both accuracy and speed, you're working on that. Okay, so this expression, we have to know the LCD first, right? Is that denominator, can it be factored any more than what it is? No. Can m be factored any more than it is? No. Can m squared minus 4 be factored more than it already is? Yes, it can. So let's write it down. So this, notice that m squared minus 4 is perfect squared minus another perfect squared, right? So we have 3 over m plus 2 plus 2 over m equals 4m minus 4 divided by m squared minus 2 squared. Right? Remember this? Remember this property that I asked you to memorize? That one? A perfect square minus another perfect square factorizes into this. X plus y times x minus y. X, this plus that times this minus that. Okay? So we're going to do that. Let's factor this. So 3, we have 3 divided by m plus 2 plus 2 over m equals 4m minus 4 divided by m plus 2 times m minus 2. Okay? Now everything has been factored. So now we can talk about the LCD. Should this be in the LCD? Absolutely. Should m be in the LCD? Absolutely. Should this be in the LCD? Absolutely. It already is. Does it have a higher power than this? No. If it did, what if it did? We would put higher power here. We would say, if this was cubed, we would say m plus 2 cubed. The LCD must contain each of the factors in the highest power it appears under any fraction. But it's got a power equal to this, so we leave it alone. m minus 2 factor. Do we have it? No. Should it be here? Yes. Are we done with the LCD? Yes, absolutely, we're done. So then we got to multiply both sides of this equation by all of this. Okay, let's do that. So m plus 2 times m minus 2 multiplied by all of the left side, 3 over m plus 2 plus 2 over m equals the same thing, the same expression, times all of the right side, all of that, 4m minus 4 divided by m plus 2 times, oops, I'm running out of ink, sorry. Let me grab a new pen. Okay, that's better. M plus 2 times m minus 2. Right, like that. Now, let's distribute, but not simplify. Just distribute. Okay, let's do that. So this, all of that, times 3 over m plus 2, plus all of that again times that. Times 2 over m equals all of that times 4m minus 4 divided by like that. Okay? All right, now let's simplify. So notice what happened. We first distributed, we didn't simplify. Now we're going to simplify. M plus 2 and m plus 2 cancel out. We end up with 3m times minus m minus 2. Like that. Plus, on this side, m and this m cancel out. We end up with 2 times m plus 2 times m minus 2. Equals, here, m minus 2 and m minus 2 cancel out. M plus 2 and m plus 2 cancel out. We end up with m times 4m minus 4. Okay? All right. So let's see here. We're looking, now we're solving for m, right? So we need to distribute m wherever we see it. In order to isolate it, we need to first distribute it. So 3m times m, 3m squared. 3m times minus 2, minus 6m, plus 2m plus 4. Oops, we have, okay, so I got to correct this. This 2 on the outside times, let me grab my thicker pen here, because these are m, this is the reverse of this. That, we have that, we can write it like that. So I'm x squared minus y squared, so I'm going to do that. So 2 times m squared minus, so m squared minus 4, okay? So I still kept the 2 on the outside. I didn't want to distribute it yet because I want to make sure that everybody's following this. So I kept the 2, multiply those, you get m squared minus 4 equals 4m squared minus 16, right? Minus, let's see, 4m squared minus 4m, sorry. Minus 4m. I am worried about running out of room here on the page, but let's see. Okay, 4m squared minus 4m. Okay, so now let's distribute the thing and move everything to the left. So we have 3m squared minus 6m plus 2 times m squared is 2m squared. 2 times minus 4 minus 8. Minus, let me bring this back to the left, minus 4m squared plus 4m. When you move these to the left, they change algebraic sign. 4m squared becomes negative, minus 4m becomes positive, equals 0. So let's combine the like terms. We have 3m squared plus 2m squared, that's 5m squared, minus 4m squared, that's just m squared, right? 1m squared. Then we have minus 6m, and we have plus 4m. That would be minus 2m. Then we have minus 8, and so minus 8, is there any other constant? No. So minus 8 equals 0, right? So this expression is an easy expression to factor. So that is equal to m minus 4 times m plus 2 equals 0, right? This quadratic expression factors into that. So then if m minus 4 equals 0, then m equals 4. If m plus 2 equals 0, then m equals minus 2. Right? So let's look back. We have two answers. Should we accept these yet? No. We need to check these guys. M equals 4 and m equals minus 2. We need to check those two values. Let's check that on my scratch paper. So let me write this down, and then I'll cover this, but let me write down the original equation. We had 3 over m plus 2. It's off the screen, that's why I'm writing it here so you can see it. 2 over m equals 4m minus 4 over m squared minus 4. And we're checking m equals 4 and m equals negative 2. Right? These are the two ones that we're checking in this. So let me take that away for a second so the screen is not so crowded. So we solved this equation, this rational equation for m. Those are the two answers we got. And we need to test to see if this is valid. So let's put the 4 in first. So if 4, we substitute, are the two sides equal to each other? We're going to check that. 3 over 4 plus 2, 6, plus 2 over 4 equals 4m. 4 times 4 is 16. 16 minus 4, 12. Divided by 4 squared is 16 minus 4, 12. So on the right, we end up with, on the right, we end up with 12 over 12, which is 1. Let me double check that. So 4 times, is that right? 16 minus 4 is 12. And then in the denominator, again, yeah. So we end up on the right, we end up with 1. On the left, do we end up with that? So 3 over 6 is 1/2 plus 2 over 4 is 1/2. Yes, it checks out. So 1/2 plus 1/2 is equal to 1. M equals 4 checks out. So let me bring this back. This solution, m plus 4, or m equals 4, it checks out. Now let's check m equals minus 2. We're going to do that here. So this we did this okay. Now let's check that one. So 3 over, substitute for m with minus 2. Minus 2 plus 2. Wait a minute. We end up with 3 divided by 0. So we've just started to check m equals minus 2, right? And we're checking m equals minus 2, and right from the start, the solution falls apart. We end up with minus 2 plus 2, which is 0, so we cannot divide 3 by 0. So right away, we can say that m equals minus 2 is not a solution. So good thing we checked, right? So that is not an acceptable solution. We toss it out. Okay? I hope this is what you ended up with in your own solution. So in other words, I hope our solutions agree. If they do, then you are really learning this in a good way. And I'm looking forward to see that. Okay. So in this expression, we have f and g. On this page, we have two expressions, right? Two equations. Right now, it's a good time for you to write down these two on a scratch paper and solve them on your own, and then come back to the video. Both of them should not take you more than 15 minutes. Okay, they're not that bad. Okay, I'm assuming that you've done that, and now you're back. Welcome back. So let me solve this. So hopefully our answers agree. So I'm looking at this, and I'm asking, can I factor the denominator? And the answer is yes, right? The first thing is we're looking for the LCDs. So yes, we can factor that out. So let's factor it. 4 times x plus 3 minus, can I factor that expression, x squared minus 9? 9 is a perfect square, right? X squared minus another perfect square. Yes, we can factor that expression into x plus 3 times x minus 3 equals, can I factor x minus 3 here? No, it's just by itself. We cannot factor that any more than what it is. Okay, now we're ready to write down the LCD, right? The LCD must include each of these factors in the highest power it appears. So 4, it just happens here, 4, right? X plus 3 is x plus 3. Does x plus 3 have any higher power anywhere else? No. It's got a power 1 here, power 1 there. So we have to include it to power 1, or the first power. X minus 3, the same. X minus 3. So that is our LCD. So we need to use this to clear all fractions at once by multiplying both sides of the equation by the whole thing. So let's do that. 4 times x plus 3. Let me move this over a little bit. And times x minus 3, which is our LCD, times all of the left side, which is 1 over 4x plus 12 minus 1 over x squared minus 9 equals all of that LCD again multiplied by the right side times 5 over x minus 3, like that. Okay, so let's distribute but not simplify. Let's just distribute. So we have 4 times x plus 3 times x minus 3. Sorry for writing so small, but I'm trying to fit all the solution in this amount of space I have. Times, we're distributing right now, right? Distribute that to the first fractions. So times 1 over 4x plus, I should have written this in terms of 4 times x plus 3. So let me do that. 4 times x plus 3. That's a 3. X plus 3. Okay, like that. And that's a 4. And so let me fix this also. 4 times x plus 3. Okay, like that. Minus, distribute all of this again to the second fraction. And I'm going to write it with factored denominator. So 4 times x plus 3 times x minus 3 times 1 over x plus 3 times x minus 3. Again, my apologies for writing so small. I'm trying to save space. Okay, so now we've distributed all of this into the first fraction and then into the second fraction. That's what it is, with the minus in between, right? Minus in between. On the right side, we can just cancel right away because it's just one term. So we have x minus 3 and x minus 3 cancel out. We end up with 5 times 4, 20 times x plus 3. So we end up with 20 times x plus 3. Okay? So now that we've distributed, let's simplify. In here, the 4 here and the 4 here cancel each other out. X plus 3 and x plus 3 cancel out. And x minus 3 times 1 is x minus 3. Right? Like that. Minus 4 times that. Remember that x plus 3 times x minus 3 is the same format as this formula. Right? That formula. So we can rewrite that in like this, x squared minus y squared. In other words, I can write that as minus 4 times x squared minus 9. Right? I can rewrite this in the perfect squared form. A perfect squared minus another perfect squared term. Okay? And on the right, what do we... Oh, sorry, no. No, let me correct this, guys. I just noticed this. So, no, this is not right. So this is... I'm going to erase this when I have a chance to clean this sheet up with my whiteout. But this x plus 3 and this x plus 3 cancel out. X minus 3 and x minus 3 cancel out. So we have minus 4. Sorry about that. So this is not right. So this is just minus 4. And I will clean this up before posting this sheet on Canvas. So minus 4 is all we end up with here. On the other side, we have 20x plus 60. Okay? So what do we have on this side? Let's add minus 3 and minus 4. We've got x minus 7. On the other side, we have 20x plus 60. So now let's move all the x terms to one side and all the constants to the other side. So x minus 20x and then 60 minus 7, move it to the other side, it becomes positive 7. So what do we end up with? We end up with minus 19x equals 67. Right? So then what do we end up with? We end up with x equals minus 67 divided by 19. Okay, so I'm going to double check really quickly here just to make sure that I didn't make any error, and then we will check this answer in the original equation to make sure that if this checks out or not. Okay, so we have the LCD figured out, then multiplying that by each of those, we got this 4 and then x minus 3, so this is okay. And then over here we should have ended up with 4, and we did like that. And then on the right side we ended up with 4 times 5, 20 times x plus 3. So that is correct. So then after that we had, let's see, so we have x minus 3, that's x minus 3, and minus 4, and then 20x plus 60, that is correct. And then x minus 7 equals 20x plus 60. So all of this looks okay. And minus 19x plus 67. So that's okay. So let's test this in the original equation. The original equation is that 1 over, I'm going to write it first, 4x plus 12 minus 1 over x squared minus 9 equals 5 over x minus 3. So our answer is that x should be minus 67 over 19. So let's check that. Okay. So 1 over 4 times minus 67 over 19 plus 12 minus 1 over minus 67 over 19 squared minus 9 is equal to 5 over minus 67 over 19 minus 3. Okay, so I'm going to need my calculator here. Let's see. So first, let's figure this out. This will be 67 times 4 minus 268 over 19, right? And so 1 over minus 268 over 19 plus 12 minus that minus 67 squared over 19. So 67 squared divided by, so we have 1 over, and this is 44, 40, everything is positive, 4489 divided by 19 squared, 19 squared. We've got 361 minus 9, okay, and then on the other side we have 5 divided by, well, let's take the common denominator here. So we have 19 is so the denominator here is 1. Then, so the common denominator would be 19. That would be 19 minus 67 and minus 57, right? 3 times 19, I believe, is 57. So let's 3 times 19, 57. So that's minus 57, minus 67. So we end up with minus 67, minus 57 over 19. So 57 plus 67, that's 124 minus 124 over 19. Okay, so in other words, that side is 5 times 19 over minus 124, or 5 times 19 over minus 124. And on the left, let's take the common denominator here. That would be 19. And 19 times, so let's see, 19 times 12, 228, and minus 268, minus 40 over 19. So this will be minus 1 over 40 over 19. Okay, that's common. After taking the common denominator, we end up with that. Okay, so minus and this result, which is, so the common denominator here is 361, and 361 times 9, and that would be a minus or negative value, plus 4489, that's positive minus 1 over 1240 over 361. Okay. All right. So then let's take the common denominator here, or let's figure out this, because we have complex fractions here. Let's simplify that. So this one will simplify to minus 19 over 40. This one will simplify to minus 361 over 1240, and equals that one 5 times 19. Let's see, so 5 times 19, it is 95, so minus 95 over 124. Okay, so the common denominator on the left would be, let's see, if 1240 can divide into 40, yep, it divides. So 1240 is the common denominator, and minus, so this is just the checking part, right? We got our answer, so let's see if it checks out. So 31 times 19, it'll end up with minus 589, and then minus 361 equals minus 95 over 124. So let's see, what do we get? So adding these two, we have 5. Let's add those two. So we have 589 plus 361. We have 950 divided by minus 950 divided by 1240 equals minus 95 over 124. And of course this simplifies to that, right? So this whole thing simplifies to this. These are equal to each other, because this we can write as minus 95 over 124 equals minus 95 over 124. So the sorry to see that the checking part of this problem was kind of messy, but we had to do it to make sure that this answer checks out. So let me bring this all on the screen. So all we did in that whole page of checking, we verified that this answer is correct. Okay, I think the screen is a little bit out of focus. Let me try to focus this for you. Okay, so we basically checked that. I put this problem here because it's not too bad to do one of these, right? Not too many of these, but to go through one of these problems that don't have a a quick answer or a very pretty answer like that. I mean, that's not x equals -2, right? It's not a very pretty answer. So it's not too bad to have one of these in our worksheet to become a little bit to go a little bit in deep into these things and to go beyond these nice, easy answers that we normally deal with. So it's not too bad to have that problem in there as well. So that's why I kept it. But the checking part was a little bit messy, but the problem itself wasn't too bad. Okay, so that was about how to go about solving rational expressions. And as you saw, a big part of it is check your answer after you have obtained them. So now this one, we transition to radical expressions, right? With radical expressions, we want to isolate the first thing we want to do, and I think we mentioned it here with solving radical. Let me bring this back for a second. If you have one radical expression in your equation, which is the example we have in this case, right? Make sure that the radical equation is on one side of the equation by itself. So it should be on one side. So is it on one side here? No. It's got a 1 next to it. We need to send 1 to the other side. So let's do that. So we have square root of 2x plus 1 equals x. When you move 1 to the other side, it was positive on this side. On the other side, it becomes negative. So now we should raise both sides to an appropriate power. What would be the appropriate power to raise this to? It would be a second power, right? Square root of 2x plus 1 squared equals x minus 1 squared. Okay? So on the left, things become easy because this 2 and the square root cancel each other out. We end up with 2x plus 1. On the right, we need to expand this. If you remember the special product formulas like I've asked you to, this would be much easier. So you could write, if not, you can just FOIL this. So x squared minus 2x plus 1, right? So this is a quadratic equation. So let's move everything to one side and set it to 0. I'm going to move these two to the other side. So x squared minus 2x plus 1. I kept everything on one side. Notice the signs didn't change. That means I kept everything where they were. So I'm going to move these two to the left, or to the other side. It's better to say. To the other side. So 2x was positive on this side. When I move it, it becomes negative 2x. Plus 1, when I move it, it becomes negative 1, and the other side ends up with 0. So let's simplify this. We get x squared minus 2x minus 2x minus 4x. 1 and minus 1 add up to 0, so equals 0. So can we solve this? Yeah, very easily, right? We can factor this out. X times x minus 4 equals 0. Then by zero product property, we know that if we have two factors that multiply to 0, that means either this is 0, or this factor is 0, or both of them are 0. So let's use that to our advantage to solve this. If x equals 0, then that's one of the solutions. Right? If x is equal to 0, that whole thing is equal to 0. Then if x minus 4 equals to 0, then x equals 4. I jumped the gun by boxing this because we haven't yet checked these answers. So we have these two answers, x equals 0 and x equals 4. Let's check back into this original equation, right? So we're going to check x equals 0, right? That one. So plugging in, we have square root of 2 times 0 plus 1 plus 1 equals 0. Right? We plugged in for x with 0 on both sides. So what do we have here? We have square root of 1. Right? 2 times 0 is 0. Plus 1 is 1. Square root of 1 is 1. Plus 1 equals 0. Does this make sense? No. So x plus 0, I should have not boxed it. Let me move this up a little bit. Like that. So x plus 0, even though one of the solutions that we legitimately found, it's not a correct solution, because when you plug it in, it doesn't check out. So no, that's not acceptable. X equals 0 is not acceptable. So let's check x equals 4. Plug in for x with 4. We end up with square root of 2 times 4 plus 1, and then plus 1, and then equals 4. Let's see if the two sides are equal. So this is 2 times 4 is 8, plus 1 is 9. Square root of 9 plus 1 equals 4. Square root of 9 is 3, plus 1 equals 4. 4 equals 4. Right? So it checks out. So this one is the only answer that is acceptable for us. Okay? And we checked it and it was okay. So you see why it's important to check your answer when you're solving rational expressions and radical expressions. Okay. In this example, we have two radical expressions. And please solve these on a scratch paper before you see my solutions. And let me bring back that page where it talks about what happens when we have two radical expressions. If you have two radical expressions in an equation, make sure that they are on opposite sides of the equation before raising both sides to some power. Okay? So, we have two radical expressions. Are they on opposite sides? No. So we got to move one of them to the other side. Does it make any difference which one? No. As long as they're on the opposite sides of the equality, we're doing okay. So square root of 4p plus 5, I'm going to move this one to the other side, equals 3 minus square root of p plus 5. So it was positive on this side. When I moved it, it became negative. Right? Now, the appropriate power to raise this to would be the second power, right? Why? Because these are square roots. So 4p plus 5 squared equals 3 minus square root of p plus 5 squared. Okay? On the left, things are easy because this 2 and this square root cancel each other out. We end up with 4p plus 5 equals. On the right, you can either FOIL this, or if you remember the special product formula like I asked you to, some of you might be wondering, what kind of a special product is he talking about? I'm talking about this one. There are 3 special product formulas that we'll be using over and over again and again, so they are worth remembering. So we had a minus b squared, which is a. In this case, b is the whole thing. It is square root of p minus p plus 5. A minus b squared is a squared minus 2ab plus b squared. So if you have this, a minus b squared, the first term gets squared, minus 2 times the first term times the second term, 2ab, plus the second term squared. What's the other special product formula? It's the same thing, but with the plus in the middle. A squared plus 2ab plus b squared. The first term squared plus 2 times the first term times the second term plus b squared. The second term squared. What's the third one? The third one is the one that we used over and over again in the some of the previous examples. So x squared minus y squared is equal to x plus y times x minus y. You will be seeing these special product formulas again and again and again. And you're seeing it right here. So if you don't remember this special product formula, expanding this will take you a little bit longer than it would than someone who remembers this special product formula. And I'm going to apply that. So this would be 3 squared, or 9, minus 2 times 3, 6 times that. So 6 times square root of p plus 5, and then plus all of that squared. So a square root of p plus 5 squared. Okay, let's simplify things. So on the right, on the left, we have 4p. We have 4p plus 5 equals 9 minus 6 square root of p plus 5 plus that squared, that power and this index cancel each other out. So we end up with p plus 5. So what do we do now? Well, we went from 2 radical expressions to just 1. So what we're going to do is now isolate this radical expression by itself on one side and move everything else to the opposite side. So remember, if you start with 2 radical expressions, you must make sure that the radical expressions are on opposite sides of the equality before you begin your solution. If you have 1 radical expression, you make sure that that radical expression is on one side of the equation and everything else on the opposite side of the equality. So let's do that. So I'm going to put this, I'm going to bring this to the left to make this positive. So 6 square root of p plus 5 equals, I'm going to keep 9p and 5 on that side, and I'm going to take 4p and plus 5 to the other side as well. So let me keep 9 and this p and this 5 on the right, and I'm going to move 4p to the other side so it becomes minus 4p. I'm going to move this 5 to the other side so it becomes minus 5. So now is our radical expression isolated on one side? Yes. Everything else is on the other side. So let's combine these terms. We have 6 square root of p plus 5. 5 and minus 5 add up to 0. We end up with 9. And then p minus 4p is minus 3p. Right? So we can factor this and divide by 6. We can do that. Should we do that? Yeah, why not? Let's do that. So 6 times square root of p plus 5 equals 3 times 3 minus p. Right? So this 3 goes away and with the factor of 3 here. So we end up with 2 square root of p plus 5 equals 3 minus p. Okay? So now, what do we do now? Well, raise both sides to the second power again. Okay? So let's do that. So 2 square root of p plus 5 squared equals 3 minus p squared. On the left, things become easy. 2 squared is 4 times p plus 5. On the right, we have to, again, expand this using the special product formulas. Remember those? The ones that I just showed you again? So they're very useful. They come up often. So 3 squared is 9 minus 6p plus p squared. Okay? So let's distribute the 4 into this. We have 4p plus 20 equals 9 minus 6p plus p squared. This is a quadratic equality. Let's move the 4p and 20 to the other side. So I'm going to keep all of these on the same side they're already on, which means I'm going to keep these algebraic signs the same. So 9 minus 6p plus p squared. I'm going to move 4p to the other side, so it becomes minus 4p. I'm going to move 20 to the other side, minus 20 equals 0. So now let's combine things. We end up with p squared minus 6p minus 4p, that's minus 10p. 9 minus 20, that becomes minus 11 equals 0. Right? Can we factor this? We should. Right? In order to solve it, we should. So factoring this gives us p minus 11 times p plus 1 equals 0. Okay? Then let's set each one equal to 0 and solve for the solution. So if p minus 11 equals 0, then p equals 11. If p plus 1 equals 0, then p equals minus 1. Should we accept these two answers right away? No. We should plug them in back into the original equation here. So we need to plug each one back in here to see if the two sides are equal to each other. Let's do that. I'm going to do that on a piece of scratch paper here. Do I have enough room to do it there? Maybe I can do it on the paper this time. I think I have a little bit of room here. So I'm going to do it right here. So let's check p equals 11. Right? You're not going to see it, but I'm going to plug 11 into this equation. Okay? So let's do that. So we have square root of 4 times 11 plus 5 plus square root of 11 plus 5. And we're asking if the left side equals 3. Well, let's see. 4 times 11 is 44, right? Plus 5, 49. Square root of 49, 7. Plus square root of 16, 4. So 11 equals 3. Is this correct? No. No. So we checked p equals 11 and it did not check out. So that's not acceptable. Okay, let's check p equals negative 1. Again, you're not seeing that. You're not seeing this is, I'm going to plug for p with negative 1. Okay, so let me do that here. It'll barely fit. So 4 times negative 1 plus 5 plus square root of negative 1 plus 5, is that equal to 3? And you can see that this is 4 times minus 1 is minus 4, plus 5 is positive 1. Square root of 1 is 1, plus minus 1 plus 5 is positive 4. Square root of 4 is 2. 1 plus 2, is that equal to 3? Yes. So we checked this one, p equals negative 1, and it checked out. So we accept only p equals negative 1. So this solution was a little bit longer than the other one, so I couldn't fit all the solution on the screen for you. but I'm sure, because I'm going to post all these notes on Canvas as well. So you can download the paper versions, the PDF files from Canvas if you like to, in addition to these videos. Okay. So this one, there was another one. There was another problem at the bottom of this screen. Please make sure that you pause the video and solve this on your own and then come back to the video. Okay, I'm assuming that you've done that. So this is fifth root of, we have only one radical expression and it's already been isolated, right? It's on one side by itself. If the 2 was right next to it, I would send the 2 to the other side, but it's already organized. So let's raise both sides to some power, but it should be an appropriate power such that it would eliminate the radical expression. So what should we raise both sides to? What power should we raise both sides to? To fifth power, right? Because this is the fifth root. Great, so let's do that. So fifth root of 3x plus 4 to fifth power equals 2 to fifth power. On the left, things are easy. This 5 and this index cancel each other out. We just end up with 3x plus 4. On the right, we have 2 to the fifth power is 32. So 3x plus 4. Let's isolate x, right? We're solving for x. So 3x equals 32 minus 4. 4 was positive on the left. When we move it, it becomes negative. 3x equals 28, positive 28, right? So x is equal to 28 over 3. So should we accept this? No. We should check this answer. Unfortunately, we have enough room here for me to check that. So check x equals 28 over 3. Okay, we're going to check that. We're going to plug 28 over 3 in that. So fifth root of 3 times 28 over 3 plus 4, and we're wondering if the left side is equal to 2. Well, 3 and 3 cancel each other out because the 3 is being multiplied by that, right? So we end up with fifth root of 28 plus 4, and we wonder if that is equal to 2, but that is fifth root of 32, right? Fifth root of 32 is in fact equals to 2. So x equals 28 over 3 is checked out, and it's an acceptable answer. Okay? I hope this agrees with the solution you wrote down on the paper, on your own paper. Okay, so here we have another expression with 2 radical expression in it. That means we need to isolate the radical expressions on both sides, right? We can't have them, we can't solve this with both radical expressions on one side, right? This is what we said in this paragraph. If you have 2 radical expressions in an equation, make sure that they are on opposite sides of the equation before raising both sides to some power. So we're going to take that advice and separate these. So I have square root of 2m minus 3 equals, I'm going to send this one to the other side. So we end up with positive square root of m plus 7 minus 2. Right? It was negative on this side. When I moved it, it became positive square root of m plus 7. Now we can square both sides. So square root of 2m minus 3 squared equals square root of m plus 7 minus 2 squared. Okay, right? Usually I put these in red so you can see it and it doesn't get mixed in with the above equation. So that's that. So on the left, things are easy because this 2 and this index, this root cancel each other out. We end up with 2m minus 3, right? On that side, we need to expand according to either you can FOIL it or you should use the special product formulas which I mentioned a few minutes earlier, if you remember them, that is. So it will be square root of m plus 7 squared minus 4 times square root of m plus 7 plus 4. Okay? Okay, let's simplify that. We have 2m minus 3 on the left. This one simplifies to m plus 7. Then we have minus 4 times square root of m plus 7 plus 4. Now what do? We end up with one radical. We went from 2 radical expressions to 1. What do we do now? Well, we isolate the one radical expression term on one side and move everything else to the opposite side. So because this radical expression has a minus coefficient, I'd like to keep the coefficients positive as much as possible. So I'm going to move this whole radical expression to the left, which would make that positive. 4 times square root of m plus 7 equals, and I'm going to keep m plus 7 plus 4 on that side. By the way, m plus 7 plus 4 is m plus 11, right? So m plus 11 on the same side. And I'm going to move these two to join them. So 2m moved becomes minus 2m. Minus 3 moved becomes positive 3. Okay, so let's simplify again. We end up with 4 times square root of m plus 7 equals minus 2m and m is equal to minus m. 11 plus 3, 14. Okay? So now what do? Well, we raise both sides to the second power. 4 times square root of m plus 7 squared equals minus m plus 14 second power. So on the left, 4 squared is 16 times square root of m plus 7 squared is just m plus 7, right? If everything is being multiplied on the inside of this parentheses, then power distributes itself to them. But if you have 4 minus or 4 plus that, we could not do that. We can only distribute the power only if the terms on the inside are being divided or multiplied. Okay, so in this case, we could do that. 4 squared times m plus 7. On the right, again, we apply the special product formula. We end up with minus m squared minus 28m plus 14 squared, which should be, what is it? 14 squared. Let's see. Remind myself, 14 squared is 196. Right? Okay, so let's distribute 16m plus 16 times 7, 112, right? 112 equals m squared, positive m squared, minus 28m plus 196. So this is a quadratic equation in m. So let's move everything to one side and set it equal to 0. So I'm going to keep all of this on one side because this is already has a positive coefficient, so it's fine. I'm going to move these two terms to join them, not bring these to this side. So m squared, notice the signs stayed the same, which means I did not move any of these. M squared minus 28m plus 196. Now, 16m is going to go join them. It was positive, now it becomes negative. 112 is going to go join them, join this group. It was positive before I move it. When I move it, it becomes minus 112 equals 0. So let's simplify. We get m squared minus 28m and minus 16m. That is minus 44m, right? Let me, 40, yes. So minus 44m. 196 minus 112, what do we get? 196 minus 112, 84, positive 84, equals 0. Okay? So then, if we can factor this, we would factor it into terms that would multiply to 84 and add up to 44. Let's see. So I don't see it right away, so I might have to use the quadratic formula. 7 times 12 is 84, but it won't. 7 and 12 add up to 19, not 44. So what else could give us the multiply to 84? So 2 times 24, no, that would not work. So let's use the quadratic formula then. So I'm going to move all the way to the top. So before I do that, so our A is equal to, let's see, so our A is equal to 1, B is equal to minus 44, and C is equal to 84, right? So let's move up, and like that. So I'm going to put that equation here again so we can see it. Minus 44m plus 84 equals 0. Okay, applying the quadratic formula would be minus 44, which would be positive 44, plus or minus b squared. B squared is 44 squared. So it's 1,936, right? That would be 1,936 minus 4 times A times C. So minus 4 times 84. So minus 336 divided by 2A, which is 2. So x equals 44 plus or minus 1,936. Right? So let's do the subtraction. So we have 1,936 minus 336, 1,600 divided by 2. So that inside is certainly just 40 squared, right? 44 plus or minus 40 divided by 2, right? That's 40 squared, so 40 comes out. So then we have x equals 44 plus 40 divided by 2. That's 84 divided by 2, or 32. No. So 84 divided by 2, 42. So that's one of the x value, or m value, sorry. Let me make this correction. So this is, instead of x, this would be m. This would be m, all of these would be m instead of x, like that. Okay, so one of the m values is 42. What's the other one then? The other one is 44 minus 40. That would be positive 4 over 2, which is 2. So m equals 42, m equals 2. So we came up with two solutions. Should we accept these? No, right? We need to check. So let's do that. So let's check the 42. Check m equals 42, right? And then so we're going to plug in square root of, this time you can see the expression right there. So 2 times 42 minus 3 minus square root of 42 plus 7 equals minus 2. Right? So let's see if the left is equal to the right side. So this is 84 minus 3, 81. Square root of 81 is 9. Minus 42 plus 7 is 49. Square root of 49 is 7. 9 minus 7, is that equal to negative 2? No, it's equal to positive 2. So 2 is not equal to negative 2. So this one, m equals 42, does not check out. Right? So that answer is out of the question. Let's check m equals 2. Okay, so plugging for m with 2. Okay, I'm out of the screen right there, so I need to scroll up. So I'm just checking the 2 in the original equation. 2 times 2 minus 3 minus square root of 2 plus 7. And we're asking if the left side equals negative 2. Let's find out. So 4 minus 3 is 1. Square root of 1 is 1. Minus 2 plus 7 is 9. Square root of 9 is 3. So minus 3 equals minus 2. So minus 2 equals minus 2, which checks out. Okay. So m equals 2 did check out. So this is the only answer that we box and accept. Okay. That's the only answer acceptable for this equation. Okay, so this next problem, please make sure that you solve this before you see my solution. Okay, so I'm assuming that you've paused the video, you wrote down your own solution, and now you're back. Okay, so this one is third root of 2x plus 1, right? So we need to raise both sides of this equality to a power, especially because the radical expression is already isolated. So to what power would you raise both sides? To which power? If you said 3, that's wonderful. Yes, we would raise both sides to third power because this is the third root of 2x plus 1. So to get rid of this radical, we need the third power. So third root of 2x plus 1 to third power equals minus 5 to third power. So this third power and this index of the root cancel each other out. We end up with 2x plus 1 on the left. On the right, minus 5 cubed. It's going to be minus 125, right? But let's check. Let's check because I'm not sure. 5 or minus 5 raised to third power, minus 125. Okay, so minus 125. Now let's solve for x. So we have 2x equals minus 125. Move the positive 1 to the other side, minus 1. 2x equals minus 126. X is equal to minus 63, right? But let's double check. 126 divided by 2, 63. And we have, of course, this minus. So minus 63. Can we accept this answer as it is? No. We need to check it, right? Let's check it. Check x equals minus 63. Okay, so we're going to plug it into this original equation. So third root of 2 times minus 63 plus 1. We're asking if that is equal to negative 5, right? Now, this is a third root. It's an odd root. Odd roots can have negative radicands, or the inside can be negative for an odd root. In other words, we don't end up with a complex number, is what I'm saying. If it was even root and we had a negative on the inside, then we would have a complex root. But in this case, no, it's not complex. So, and it's allowed to be, the radicand is allowed to be negative if you have an odd root. Fifth root, third root, ninth root, seventh root, 11th root, all of those odd roots allow the inside to be negative. Okay, so we have the 126 again. So third root, oops, let me change this color. So third root of minus 126 plus 1, and we also, okay, that parenthesis shouldn't be there. I will clean this up before posting it on Canvas. Okay, so we ask, is that equal to negative 5? This is minus 125, right, after you add 1 to it. So third root of minus 125 equals, is that true? And yes, third root of minus 125 is minus 5 equals minus 5. So the left side equals to the right side. So this answer we can box and accept as a correct answer. I hope this matches what you had on your own paper. Okay, so that's how we deal with solving rational equations and radical equations, and I hope this video made things a little bit more understandable. If there were some vague areas in the textbook or in my lecture in class, I hope this video clears that. So thank you for persisting through this video, and I will for now have a nice day, and I will see you all again next time.